Hi there. To get ready for our next synthesis recipe, which will be a lead synth done in SuperCollider, just very briefly, a little bit background on wavetable synthesis, and I'll show you a couple of UGens that are very handy in SuperCollider to perform wavetable synthesis. Just a tiny bit of theory. Basically, any oscillator, digital oscillator, really is a type of wavetable or wavetable synthesis or oscillator. So, for example, the SynOs UGen in SuperCollider, or just in practically any other synthesis device, is using a table, just a table of values, of amplitude values, and it looks it up, and it sweeps through the table at different speeds to give you different frequencies. So here's a representation of a sine wave, and as you know, as the oscillator sweeps through, it's going to grab a different amplitude value from the table, and then generate that sine wave. And obviously, the faster you read through it, the higher frequency. The slower you read through it, the lower frequency, and that's how you get a change in pitch. Okay, so using that basic principle, you can really have any wave form in a simple wavetable, and then have your oscillator read through it. So it'll read this, and it'll create different, harmonics or different types of sounds doing that. Okay, so basically that's what we're going to do in SuperCollider. We're going to use an object to read through different waveforms, and I'll show you where to get, or maybe even give you some wavetables to use and play around with, and there's some in the exercises of SuperCollider. One of the things that wavetable synthesis often does is it combines several waveforms, or maybe two, and you can interpolate between the two. And so I have a sort of a helper little tool that allows you to listen to different waveforms, and then maybe put it in to a thing where you can interpolate between the two waveforms. Okay. So SuperCollider has this nice object called VOsc3. And if we look at it, basically, it takes this buffer position, which will allow you to interpolate between two different buffers, which are holding your wavetables. Okay, so that you're going to populate these audio buffers, but they're going to be small, very small, like 2048 samples long, and they will hold. So if you, they will hold buffers. They'll hold the wavetables in them. All right. Now VOsc requires a couple things. If you go to the help file. It needs to be that the two buffers are power of two, but that they are adjacent to each other. Okay, so when you create the buffers, I imagine if you create them one after the other, then they'll be on adjacent buffer numbers, or you can explicitly create buffers that are next to each other, and they have to be the same size. So if you have a wavetable that's 1024 and then another one's 2048, it won't interpolate between the two. It creates actually 3 oscillators based on your wavetable, which is nice. It gives you some nice harmonics there. So we can look at the arguments just slightly here. And again, buffer position interpolating between 2 adjacent buffers, and then the frequency of the 3 oscillators. Okay, and then the multiply and add if we use them or not. All right. So I have built a little helper here called my wavetable synthesis. All right, I've built a little helper, and what this does is it loads a load of wavetables that I kind of gleaned online, and I have made from the examples, the help code. Okay, and you can actually get those if you go to my GitHub page. You can get all of my code. It's all just up there. So I think I have a repository called tutorial code. So if you're interested in that, you can download everything. I think everything that I work on goes up there, tutorial code. But this one happens to be in the one called wavetable synthesis. Okay, and then there's a bucket of wavetables there. A lot of them I gleaned from this architectural waveforms. I was following the Circle synth, and they recommended, and they have like a free demo, so that some of these are theirs as well. And then the other ones are gleaned from the examples. I just changed those into audio buffers. Okay, so right. So what I do here is I won't talk you through the whole code. I'll just show you how to use this as a helper. and then in my next synthesis recipe, I'll use them. Okay, in my lead synthesis recipe. Now, what this does here is it loads all those sound files there into buffers. Okay, and then it has a couple of synth defs that just center around that object and allows you to sort of interpolate between the different wavetables so you can see. So the first step I would recommend is, well, let's boot up this here. And this will boot and load everything up for you. Okay, and then I'm going to run the first one, wave shape test, and this now has a collection of all the wavetables that are in that folder, and using your mouse X, it'll let you interpolate between them. So that way down. Okay, so as I move my X, I can listen to the different waveforms there. And see, it's just interpolating between two adjacent buffers. At my mouse X, it tells me where to interpolate between the two that I like. So I'm going to pick the timbre I like there. So maybe 0.65. Okay, let's do that. So I'll put in this offset 0.65. So that just means that it's going to be, 65% of Wavetable B and 35% of Wavetable C. Okay, and it nicely lets you interpolate between the two. And you'll see this, for example, in that commercial synth circle out of Future Audio Workshop out of Berlin. They use this. This is one of the things they use, is this interpolating wavetable. They have a wavetable synthesis, so it's one of their oscillators. And basically, wavetable synthesis, it's maybe not the end all and the be all, but it's nice. Gives you a nice little alternative. So oftentimes in subtractive synthesis, you are combining sawtooth waves and triangle waves and sine waves and such, and then making, doing some filtering and such after that. This gives you just another alternative, which I think the folks at Future Audio Workshop really stumbled on nicely, is that it gives you another alternative for another waveform. So instead of just going to the same sine waves and such, which you can do, worlds of music with, this gives you some additional color. You can add sort of a unique flavor to your synthesis. Okay, so that's done, and I've picked my offset. So this is kind of the final product. Then the final just basic synth def here, wave tab that just has the fixed buffer offset without the mouse X interpolation, So I'm just going to grab the one with the fixed offset. Of course, you can change that on the fly. It's an argument, but this is the thing I like. So we're going to grab that waveform now, and this is just interpolating between the two wavetables, and then I can change my pitch. Still sounds pretty nice low. Sounds pretty good high too. Okay, so there you go. So this is a little helper tool under this Wavetable Synthesis SCD to use and to find your way through different wavetables and to choose some. Basically the main thing is that you grab two adjacent buffers with wavetables that you like, and then you find an offset between the two, or you can just continue to play around and change the offset to see which ones you like. All right, so let's just pop it into my lead synth, and there's going to be a whole nother tutorial with going through this whole lead synth, but I want to give you an idea. This is sort of a prep for that, because when I do the tutorial, I'll just sort of refer back to this tutorial. So basically, I just grab these two buffers here under WTB1, WTB2. So I'm going to grab the two buffers that I like, buffer read here. And this is also presuming you have your wavetables all in the same place still. Okay. And so I'll pop that in there. Right. Did I do that right? Too many buffer reads. Okay. Okay. And then I'll grab this whole thing again. And then I'll pop that into the second one, WT2. Okay. So then that becomes a wavetable I can use within this, in this lead synth. Where is it? Where'd it go? Right here, VOsc3. Basically takes, and I've done a slightly different, because I guess I'm making a mono. Am I making a mono? Yeah, I guess I'm making a mono synth. So, I've just taken these two frequencies there, and I've have this WT buffer, wavetable buffer, off plus offset. And, I have this fixed offset, which, again, that's another thing we need to change, is this 0.65. So I have this fixed offset here, 0.65 here. Of course, that's modulatable because it's an argument. All right, so then if we listen to that, and again, this will be its own tutorial, so check it out if you want to do this lead. And we'll run that, and we'll play the synth. Okay, well, hopefully that was helpful. Just some basic covering of wavetable synthesis. I explained it, kind of what it was, give you a few helper apps. This was kind of a more general one, didn't go through line-by-line code, but it gives you an idea of how to use this object VOsc3 to produce some pretty interesting waveforms. And like I said, I would recommend that you certainly can use it on its own, but in the context of this a larger subtracted synthesis as one of your oscillator choices, it really does add a lot of richness to the possibilities you can do with synthesis. Instead of just going to sawtooth or sine waves all the time, you can have a third ingredient that does do some pretty interesting things. And this gives you access to, if you go to my GitHub or call these on your own, you can find these all over the web. It gives you a chance to the Daily Mail, and the dog. Okay, so right, so it allows you to collect. You can go get these wavetables around, and you can even buy them, and you can make your own too. There's a neat little tutorial. Use Audacity to create these wavetables yourself. Here it is. Here is Groove Sizer. You can go to that link, and you can use Audacity, which is free, open source, and create wave shapes and then draw in the thing. And it's worth exploring. I did a few of these, and they kind of ended up sounding a bit the same, but I'm sure if I was to spend some time with it, you can create some really interesting wavetable shapes. But there you go. I think that's very, very interesting. You can just draw in some waveforms, and maybe even copy ones that look like slightly like square waves, a little off, or slightly like sawtooth waves, and just see where you go from there. I'm sure there's some shapes that I just didn't explore enough. There's some shapes that might really render some interesting sounds. Okay, so check that out as well. But wavetable synthesis, there's a load of commercials and Rolands and such that use this and use these wavetables. So this allows you to do it for free and to do it within SuperCollider. And hopefully that was useful to you. Okay, well, good luck with that.